C. Saranya Chejilla. Welcome to EasyP Tech. Today in this class, we are going to learn about what are the different type of collision-free protocols. Right. Okay. So in the previous classes, we learned what is meant by collision and what are the different types of protocols to how to identify the particular collision in the transmission medium or a channel, or how can we detect a particular collision, how can we avoid a collision. In these all topics we already read in previous classes. In this, the collision free protocols, and there is no concept of collision here. Let us get into the topic. What are the different type of protocols to free and collision while transmitting data from source to destination, uh, by using a single channel or shared channel, right? Let us get into the topic. See, collision free protocols. In computer, when more than one station tries to transmit different type of data frames from source to destination, so in that time the collision will occur because more number of stations using a one channel or a shared channel. Okay, so this in that case a collision will be occur. Like we have a different type of random access protocols like Aloha, CSMA, CD, and CSMA, CA. So these are the different types. How can we identify that collision occur in the station? How can we detect whenever collision occur while transmitting data from source to destination? How can we avoid the entire collision? Right. So these are the different types we already see in the previous classes. Here there is a concept of collision free protocols. Collision free protocols. This mainly used to resolve the collision in the contention period, and so the possibilities of collisions are eliminated. Here, the collision free protocols are used to resolve collision in the contention period, and so the possibilities of the collisions are eliminated. So that is the concept of collision free protocols. What are the different type of protocols we have to free a collision in our particular shared channel when two or more users using to transmit data frames from source to destination by using the channel. So see, these are the different type of collision free protocols: Bitmap protocol, binary countdown, limited condition protocols, adaptive tree walk protocols. Here, adaptive tree walk protocol is a sub protocol of limited contention protocols. It's a sub protocol of limited contention protocols. Okay, see, these are the different type of collision free protocols. The first one, bitmap protocol, binary countdown, and the third one, limited contention protocols, and that is the adaptive tree walk protocol, and this is the sub protocol of limited contention protocols. Let us see each and every protocol. How can it eliminate the collision while transmitting data from source to destination in a shared channel? Okay, right. See, what is meant by bitmap protocol? Let us see. See, in this bitmap protocol, the contention period is divided into n slot. What is meant by contention period? Means transferring time. So this particular period is divided into n slots. Why? Means here, whenever while communicating data from source to destination, we have allotted one type. Okay, or 10 to 10 or 9 to 10, we allot this time to communicate data from source to destination of one or more stations by using a shared channel. See, this contention period is divided into n slots, where n slot is equal to number of stations, where n slots is equal to number of stations, right? So here the particular time will be divided into number of slots. How many number of stations are using or sharing that particular channel, this number of stations will be divided into number of n slots. Number of n slot, the contention period will be allocated or divided into n slots and will be allocated to all the stations who are working by using that particular channel, right? So if a station has a frame to send, if a station has a frame to send. It sets the corresponding bit in the slot. It sets the corresponding bit in the slot. While the contention period divided into n slot, if a station want to send a frame, so it gives an indication to the channel. I want to send a frame. Here, the particular corresponding bit will be assigned to that particular station. What it indicates? What it indicates means just communicate that frame into by using that channel. But here there is one main concept will be there. Before transmission, before transmission, each station knows whether other stations want to transmit or not. Okay, so I am in one type of user by I am using an one type of channel here, so that channel will be shared by the number of users, right? Okay, so when I want to communicate a data from to the destination, I want to know here any other users are ready to use that particular channel or not. I want to know that, because if anybody want to communicate that particular channel, there will be a collision occur. This is what collision free protocols. There is no matter of collision. Here, whenever the particular station want to send a frame to their channel, to the shared channel, before transmission, each station must and should know whether the other stations who are using that particular shared channel, the other stations want to transmit or not. If the other stations want to transmit, the stations must understand by a mutual agreement. We will be the better understanding, nothing but an to better understanding means to give an agreement, like an agreement. I want to send a channel first, like next time you send the channel. That's a mutual understanding means. Mutual understanding must by the mutual understanding. So here collisions will not occur whenever the collisions want to eliminated the particular channels have a mutual understanding or mutual agreement among the contention station contention period. Who gets the channel first, who want to communicate a particular frame in that channel. Okay, so after communicate that frame, next uh, the channel will be allocated to next station. See, I will see I show one diagram here how the contention period will be divided into n slots. What are the stations want to communicate, how the mutual agreement will be there in between stations to use that particular shared channel, right? Okay, see, this is the diagram. This is the bit protocol. So this is an actual period. Okay, so this period will be divided into 8 contention slots. We have a 8 stations that use a shared channel. 8 stations will there. Okay, 0 to 7. So I'll divide that particular time period into number of slots, 8 slots. Here in the first time, the first station 1, station 3, station 7 want to send a data frames. 1, 3, 7 want to send a data frames. So each and every, so while communicating the data, it'll give an corresponding bit to the each and every station. See, corresponding bit 1 for station 1 because they want to communicate, so will be assigned station 3 and station 7. So these 3 stations want to communicate data frame by using the shared channel. So in this time there will be a mutual agreement between these stations. There will be a mutual agreement between these stations to eliminate collision in between the channel while transmitting data from source to destination. See, in that if the station 1 used this particular channel, okay, so the station 1 we have to know there are any other stations want to communicate. Yes, The 3 and 7 also communicated data frames here. But here a mutual agreement will be done by an 1, 3, 7 stations. 1, 3 and 7 stations. There will be a mutual agreement done. Here, whenever this mutual agreement is successfully done, there is the elimination of collision will be there. Elimination of collision. So first the station one will be communicate data frame. After that it will be assigned to the station 3. The channel will be assigned to the station 3, and after that time the channel will be assigned to the station 7. Okay. Okay, so next, this is the another example. Here, two stations are allocating. Two stations or want to send a data frame into the by using the channel to the destination. Here, see, I'll give a corresponding bit to one station one and station 5. So there will be a mutual understanding between two these stations. The first only one station will communicate by using that channel to eliminate collision. After that, the remaining station will be communicate at that particular time period. At that particular time period, see, at that particular time period only how many stations want to communicate. That is the main thing. If two or more stations want to communicate, there will be a mutual agreement will be those stations who want to communicate first. After communicate the first station, then the channel will be released to the another station. That's why in this particular period, okay, in this particular period, the channel will be allocated to the stations one by one by using a mutual agreement to eliminate the collisions, right? And next, third time, I have a only one station that want to communicate. There is no problem here. So, but in that time also, the second station want to know is any other stations want to communicate in this particular period of time. No other stations are there to communicate a data frame in that channel. So, the station to communicate a data frame. See, here the time is divided into n number of slots, and the time will be allocated to each and every station. In that particular time, there are two or three more stations are divided. In this time, you have to communicate. In this time, you have to communicate. In this time, you have to communicate. That will be given. So, if one time period, two or more stations want to communicate, there will be going in mutual agreement between that two stations, and if the mutual agreement is successfully done, to eliminate we can eliminate the collisions, right? So this is an okay, uh, bitmap protocol. And the second thing, binary countdown. So this protocol overheads the 1 bit per station of the bitmap protocol. Here in the bitmap protocol we have we are divided that contention periods, and we are allocated at different time periods. Okay, in that particular time period how many stations want to communicate, these all the things we see in the bitmap protocol, right? So this protocol overcomes this particular 1 bit assigned to the station is will be eliminated by using this binary countdown. Here binary addresses binary addresses of equal lengths binary addresses of equal lengths are assigned to the each station. Binary addresses means for example 0001, that is the 10010 second. So this is an priority based, right? So if there are a number of stations, okay, 8 stations, 8 binary bits will be allocated to each and everything. But here the binary addresses will be allocated to each and every station by using an higher priority. By priority based, we can communicate, or we can take that particular channel to communicate our data frame to the destination, right? Here also we have a one example how the binary address will be allocated to each and every station, and which station has the highest priority uh, to take that to communicate that particular data frame to the destination, right? Okay, let us see the diagram here. So this is the This is the binary countdown. I have a 10 stations, right? These are the stations, 10 stations, and each and stations will be allocated by binary addresses. So double one double zero. Double one double zero means we have 1, 2, 4, 8. Right? Okay. So these are the 4 bits. So double one double zero means 8 4 12. That means C 10A 11B 12C. Okay. This has an 12. Like second station will be allocated 1101. I think 13 means D. In hexadecimal format, his is D. Okay. So this is 2. This is 1, 4, 5. So like that, the some binary address will be allocated to each and every station. In these particular stations, which station has the highest priority, highest number, that station will be communicated first. After that, after the completion of that particular station, the next highest priority will be next highest priority station will be given that channel. So like that, here each and every stations will be assigned some particular binary address. In that binary address, which station has the highest priority, the highest addresses, that station will get an highest priority, and that station only communicate particular data frame by using that channel. After that, after completion of one station, it will checks again what are the remaining stations highest addresses and highest priority. Then second highest priority station will be allocated by to that channel. Okay. So this is another collision free protocols and binary countdown, and we have a third. So the third one is limited contention protocols. So this is another type of protocols. These protocols combines the advantages of collision based protocols and collision free protocols. See here, the limited contention protocols uses is there any light load? Light load means is the data frames will be less. It uses an aloha scheme. Is then the data frames will be high. It uses an bitmap protocols. So I this is an one type of protocol that combines the advantages of both collision based as well as collision free protocols. So alocus as well as we use an collision based protocols and collision free protocols. In collision based protocols, it uses an aloha scheme. In collision free protocols, it uses an bitmap protocols. See, this is a diagram. So this is a diagram. Okay. So here the leaf nodes are the stations and these are the frames. The leaf nodes or the stations. Here why the leaf nodes or stations, leaf nodes will be act as and stations means here each stations is divided. See here why the number of stations will be divided into two means whenever we want to communicate data by using that particular channel, whenever there is a chance for an collision while communicating data in that particular channel, there is a chance of collision, and each the stations will be divided into number of groups. Here A B C D is then one type of group and E F G H is another type of group. So in these groups only one station will communicate at a time. One station is communicated data frame at a time to the destination, right? So this uses on both collision based as well as collision free protocols, right? These are the different type of collision free protocols. Like that, we also have a control access protocols. Control access protocols means to control the channel access. To control the channel access, we also once see that particular thing. What are the different uh, control access protocols. Let us see that what are the control access protocols, right? So these are the control access protocols, reservation, polling and token passing. I'm just telling what is the channel access. We have to control the channel access also. So these are the different type of channel access, control access protocols to reduce the channel access. Okay, so let us discuss a small thing about this. Reservation. The reservation is one of the control access protocol to control the channel access, right? So I will show you diagram. Here the reservation means whenever the stations want to communicate, a data frame in that particular shared channel, it gives first of all the stations get ready to reservation. Get ready for reservation. See here we have a 5 type of stations. I explaining the diagram here. 5 type of stations. Okay, so this particular stations will be the channel will be divided into number of slots, and 1 2 3 4 5 are the stations. So here no station is in the reservation. No station is in the reservation, right? So if the particular station want to use an communication channel to communicate a data frame to the destination, first of all it reserves the time slot, means that particular channel. It reserves that particular channel. So here data station 2 want to communicate. That will be the request will be given to that channel. So it allocates like an bitmap protocol only, so it allocates one, the station 2, as the particular channel is assigned to the station 2, right? Okay, so again in the second time, okay, the three stations want to communicate. So station 2 and station 3 and station 5 want to communicate, right? So here the first reservation is station 2. Okay, that the first channel will be allocated to the station 2. After the completion of station 2, the next is a priority based. Next is station 3. After that station 5. So like that, after completion of the one station, the next the channel will be allocated to the other stations. But before assigning the channel to a particular stations, the stations will be reserved that particular time period. Okay, like this we can we can control the access of the channel. Okay, every time. Next, polling. Polling means here the concept of we can say this is an primary and secondary devices, like we can call in other words a server and clients devices. We have only one primary device, and we can have any type of secondary devices. It's nothing but an server and a client communication. Polling means whenever the particular primary device want to receive the data. Okay, so the particular acknowledgement will be given, that is an polling. So poll, when this particular poll symbol is done by an primary device or the server to a particular secondary device, here data frame is ready to communicate with the primary device. It will give an acknowledgement. Or data frame. If the data frame is ready, whenever the poll symbol is received by that particular primary device, it will send a data frame. Otherwise it will give negative acknowledgement. So here the primary device means server, and these are the clients A and B, or the clients. If the primary device want a data frame for data frame from a device. So it give an indication is pole. Pole means want to receive a data frame. Okay, if the a device has a data frame, it will send a data frame. Otherwise, it gives a negative acknowledgement. See, it gives a negative acknowledgement. NAK means negative acknowledgement. Means currently the A device does not have any data frame to communicate with the primary device. So, okay, that primary device leaves that A client. Then another client. The primary device that gives an pole indication to another client. Only that particular network, so whenever the B has a data frame, so in this B has a ready data frame, the data frame will be given to the primary device, and whenever the primary device receives that particular data frame, it gives an acknowledgement. So this is a polling concept. Here it's a very different concept. Here we have a communication between a primary device and secondary device. Here there is no communication channel shared and a next source and destination, nothing like that. Here server and client communication will be happen by using a different words, pole and select. Pole means the primary device or the server wants a data frame. Select means the primary wants to sense a data frame. The primary device, whenever the pole indication, the primary device want to receive a data frame. Whenever the select will be there, the primary device want to sense a data frame to a particular secondary devices. Here, the second diagram, look at the second diagram, we can easily understand that. So here the select command will be given to the B device. Okay, select command means that particular primary device want to send a data frame to the B device, and he gives an acknowledgement. Okay, I'm ready to accept that particular data frame from you. So whenever the positive acknowledgement received by a primary device, okay, so the data frame will be sent by a primary device to secondary device, and he given an acknowledgement. Okay, I received that data frame. So this is a one type of control access allocation. This is polling. Polling means to receive data frames, and we can send data frames from different clients to server or server to client. Like that, it will act. It will act like that. And also we have another thing. Another thing means so token ring. Actually, the token ring is a very useful unidirectional communication in a ring topology. We use this token ring. So the IEEE, we have a IEEE format for token ring also. It is 802.5. 802.5. Okay, so whenever the IEEE standard given a particular ring, it is very efficient efficient way to communicate in ring topology. What is the purpose of an token ring means here to erase to eliminate an collision, or the only the channel will be allocated to the particular station. Only at a time, only one station can use that particular channel. Here token ring concept will be raised to control that channel access. If the stations wants to communicate data, it is a unidirectional communication. So this is a ring topology, right? So in this ring topology, there is no chance for a bidirectional communication. We have only unidirectional communication. Okay, if the station wants to communicate station 4, only clockwise direction is possible, unidirectional. So here, if any station in the ring topology want to communicate with other station, the station must take the token. Here token concept will be raised. If the token assigned to a particular station, that station only can communicate data frames to the destination at a time, and remaining stations who connected to the particular network that should be in an ideal position.
That should be is an idle position. After completion of one station communicating a data frame, after this process will be completed, the particular station releases token, and that token will be assigned to the next priority, next channel who connected to that, next station who connected to that, right? Sorry, next station who connected to that. So after completion of that one station, then only the token will be released. If the token will not be released, that station will be communicated at so many times, or so much time. Okay, so after the process will be completed, the token will be released, and that token will be assigned to the next station who connected to that network. Okay, this is the token ring concept. So if you want to communicate in ring topology with other stations, you need a token to communicate a data frame from source to destination. These are the different types of control access protocols. Means to control the channel access. These are a small topic. You have just an idea of an control access protocol, reservation, polling, and token ring. So these the mainly we need and collision free protocols, bitmap protocols, binary content, and limited contention protocols. These are the three major collision free protocols, right? I hope you understand each and everything. Kindly like, share, subscribe EasyBTech for more videos. Thank you.